Yeah, welcome to Data Analysis Scholarship course. This is week 5 of this scholarship course. Today we will be looking at data analysis as regards to inferential statistics. Welcome tonight. Welcome once again. Welcome once again for tonight's section. My name is Franklin, and tonight we will be starting a journey on inferential statistics, data analysis, where we will be focusing on inferential statistics. Starting this journey tonight we will understand what inferential statistics is all about. Good deep dive into what we look at: hypothetical testing, test of hypothesis, understand the null hypothesis, understand the alternate hypothesis, and from there we head into the t-test, where we will be looking at the one sample t-test, paired sample t-test, independent sample t-test. After that we delve into practical sections, real life practical sections as regards to data analysis. Tonight we will be focusing on inferential statistics. Don't worry, even if you don't have statistics background, you don't need to be afraid of tonight's section. I'm going to break it down to the simplest term that even a 5-year-old will be able to understand. So even if you don't have any statistics background, mathematics background, you don't even need that to learn data analysis. I'm going to break it down for you tonight. Once again, you are welcome. My name is Franklin. Let me know if you can hear me, if you can see my screen, much appreciated. Let me know if you can hear me, if you can see my screen. Also, let me know where you are joining me from this night. Let me know your name, your location, where you are joining us from tonight. And also, as our tradition is, those of us in the scholarship group, those of us in the scholarship, I will want us to quickly go to the scholarship group, tag everybody. We are now in the advanced aspect of Excel. Tag everybody. Let them know we are live. Let them rush down to the section tonight, because we are getting into some of the stuff that most of us will love to do, and these are certain things that makes you read data analyst: the ability to interpret data, the ability to use data to make decisions, the ability to use data to analyze trend and say, I'm confident that this will happen based on the data we have. All right, Amen, good to have you. Amina, good to have you. Good to have you guys. Let's do that as our tradition is. Like the live section, go to the scholarship group, let them know we are live, and share this link to at least 1 or 2 persons that you know will be needing this knowledge this night. By sharing it, you are helping to spread the good news of data analysis. You are helping to encourage someone to be good in data analysis. And I have said this before, and I will repeat this again. A data analyst is highly sought after across the globe. There is no organization without data, and there is need for data analysts in order to bring this data to life and cause organization to make legit, informed, and profitable decisions. So let's go ahead and do that. Amina, thank you for having done that. If you have done that, just type done. Just type in the comments, in the chat box, done. Just drop in the chat, done. Because we are going to go straight into what we have for tonight's section. Only Amina that I'm seeing your chat, only you that is saying done. How many persons on this live? Go ahead and click the button done. Go ahead. If you have done that, let me know. type in the chat, type in the comment, done. If you have shared the link, if you have liked the section, this live session, and if you are in the scholarship group, if you have dropped in the group, we are live. Just type there, done. All right, Amen, Eset, thank you. Thank you, good to have you, good to hear from that, good to get that from us. All right, now, without further ado, let's get into what we have. Let's get into what we have, tech and management. And my name is Franklin. Without further informations, which we have already known about me, I'm a data scientist, I'm a data analyst, a seasoned one at that, with over 7 years of experience as regards to analyzing data and then making use of data across sections, education, tech, and what have you. So tonight, I'm going to be taking us a bit on theoretical part before we delve into the practical part. I'm a believer that every data analyst should understand what it is theoretically and at the same time understand it practically. That's why most times I bring the theoretical aspect and then we delve fully into the practical. Now tonight, what is inferential statistics? I remember in our first class on this scholarship course, I introduced data analysis and I talked about the types of analysis, data analysis, and one of them is what we call inferential analysis, inferential statistics, where I said that inferential statistics is all about you making a guesswork, predict, educated guess based on certain observations, making some inference, saying certain things, not based on it enters your head, but from observation, from educated guess, from data, you make predictions. And that is inferential statistics. So tonight we are going to be defining inferential statistics. Now, we said that inferential statistics is the branch of statistics. Now, when we talk about statistics, please note it's all about analysis. Statistics is built on probability. The statistics is built on probability. The mathematics of 0 and 1, that's what statistics is built on. So when we say inferential statistics, just know we're still talking about inferential analysis. So we say inferential statistics is a branch of statistics that allows us to make predictions. Now these predictions are based on educated guess, based on observations and what have you. Like I gave us an example previously when Newton was reading and observed that a fruit fell down. He was like, for this to happen, he just predicted, he just made that prediction that there must be a force. Make that inference, make that observation, that there must be a force that is acting downwards that causes this fruit to fail. That's a case. That's what we refer to as hypothesis. So it's a branch that allows us to make prediction, make hypothesis, test hypothesis, and draw conclusions. We predict, we state hypothesis, we test the hypothesis, and then draw conclusions about the population based on a sample of data. Previously, we have explained what population means and what sample means. And I have told us that in real life, we don't analyze based on population. We don't analyze using the population. We analyze using the sample because it is nearly impossible. I will say it is impossible to get the full population of the sample statistics. So when we talk about inferential statistics, statistics is an analysis. It's analysis that allows us to make predictions, to make inference, to state our observation. Then that prediction, that stating our observation, stating our hypothesis, then we test it. We check if what we say, if the things we state, if our observation is true or false. If our observation, if our prediction, if our hypothesis will stand or not. That's inferential statistics. That's what we refer to as inferential statistics. Now, having established that, we move to difference between descriptive and inferential statistics. I'm going to summarize the difference in two words. And that is that in inferential statistics, we can predict about the bigger picture. In inferential statistics, we can predict about the bigger picture. Why in descriptive statistics, we are saying exactly what it is. What the data says is descriptive. This data is white. We are saying it's white. The number of students in class is 20. We are saying that is 20. That's descriptive. We can count it. We can describe it. That's descriptive statistics. We say that this person, the person before me is 5 meters tall. Is descriptive. We are saying what the data says. We are saying exactly what it is. But inferential, it gives us room to make prediction, to go deeper into the data. The descriptive gives us room to describe the data based on the surface. The descriptive gives us access to talk about the data on the surface. Why inferential gives us room, gives us access, gives us privilege to talk about the data on a deeper level, to go deeper, to go more deeper, to talk about the data. That is inferential. That's the difference between descriptive. Descriptive, we can say on the surface. Inferential, we can say deeper. Go to talk about the data, to think more deep, to get more insight from the data. That is the difference between inferential statistics and descriptive statistics. All right. Now, having established that, we go further into hypothesis. Remember, we say under inferential statistics, we state hypothesis. We can state hypothesis. And what is hypothesis? It's an assumption. Your hypothesis is an assumption. You are not sure that what you said will happen. Hence, is not certain. So when we say hypothesis, it falls under probability. It falls under probability. Follow me this night. I'm laying a powerful foundation this night that will determine your ability to interpret data and draw conclusion meaningfully. If you lose this session this night, if you don't understand these stuff, you will not be able to make certain decisions as regards to data, as regards to data available to you as a data analyst. So when we talk about hypothesis, hypothesis is all about you making an assumption. Hypothesis is all about you stating something that you are not sure. Hence, you need to validate the statement. You need data to validate it. You need data to confirm whether that statement stands or not. Hence, in hypothesis, there are two types of hypothesis. There are two types of hypothesis. Number one, we have the one we call null hypothesis. The hypothesis before us, we call it null hypothesis. And what does hypothesis say? The null hypothesis says there is no significance. So the null hypothesis, this is a no effect or no difference statement. So when we talk about null hypothesis, it comes from the negative hypothesis, where you are saying there is no significant effect, there is no significant difference, there is no significant impact, there is no significant relationship. So it assumes whatever you are testing shows no statistical significance. That's what we are saying here. It assumes that whatsoever you are testing shows no statistical significance. In other words, when we are saying no statistical significance, please get this. We are in hypothesis, sometimes we test the mean of the sample data. When we test the mean of sample A and the mean of sample B, what null hypothesis is saying that the mean of sample A and mean of sample B are equal. There is no significant difference. Even if they are different, it's a negligible stuff. If the mean of this is 4.8921, the other one can be 4.8920. It's negligible significance. So the null hypothesis is saying there is no statistical significance. When we test the sample mean of various data, that there is no significant difference, there is no significant effect, there is no significant impact, there is no significant damage. That's what he's talking about. So hence, the stuff is saying nothing is happening. In a nutshell, the H naught, null hypothesis which we represent with H naught, is saying in a layman's way, in a simple term, nothing is happening. I repeat, in a simple term, in a layman term, is saying nothing is happening. So when we talk about null hypothesis, just look at it as a hypothesis that is saying whatever you are saying, nothing is happening. There is no damage, nothing is happening. There is no difference. The students, this SS1A class, their SS1B class, there is no significant difference in their result. There is no significant difference in their result. That's what null hypothesis is saying. All right. Now, having established that, we move to the other one, which we call alternate hypothesis. We have two types of hypothesis. Remember, the first one is the null hypothesis, which comes from the point of no effect, no difference, no significance. Why the alternate hypothesis, from the word alternate, is the opposite of null. Is the opposite of null hypothesis. And what that simply entails is that it comes from the point that there is significance. It comes from the point of there is significance. So alternate hypothesis, this is the opposite of null. It claims that there is indeed a difference or effect. There is statistical significance. The sample A and sample B has statistical significance. Is that significant difference? Is that significant effect? Is that significant damage relationship, depending on what you are testing on? So having established that, which is very easy for us to state, we conclude that H1, which is alternate hypothesis, is simple, something is happening. Null hypothesis is saying nothing is happening. Alternate is saying, oh, that something is happening. When this person, when he's saying no, nothing is happening, the alternate is saying, no, you are lying. I'm not sure what you are saying is not true. Something is definitely happening. That's alternate. That's what alternate hypothesis is all about. So having established that, we move to the stuff when we test our hypothesis. Now there is what we call hypothetical testing. The hypothetical testing, we state our hypothesis. When we state our hypothesis, we carry out our test. There are 4 steps. I'm not really going to tonight to take us a kind of deep into it, but in hypothesis, test of hypothesis, or what we call hypothetical testing, there are 4 steps. First is you state your hypothesis. The second, you test your hypothesis, you carry out the hypothesis. Thirdly, you interpret the hypothesis. And then fourthly, you make your decisions. So in hypothetical testing, test of hypothesis, we say number 1 in test of hypothesis or hypothetical testing is that you state your hypothesis. And stating your hypothesis as an analyst, generally accepted standard, you come from the null hypothesis. Your hypothesis is saying there is no significant difference. Your hypothesis is saying there is no significant damage. Your hypothesis is saying there is no significant relationship. As an analyst, you start your hypothesis from the null. And then when you state your hypothesis, the next is to test that hypothesis, to run a test to confirm. Now when you run the test, when you test your hypothesis, then you interpret your results. And why am I stating that? When you state your hypothesis, you are stating null. When you test your hypothesis, you are using tools to analyze to get the result. You are conducting analysis. Then to interpret is base your interpretation as an analyst. Please pay attention and get this. Your interpretation as an analyst to draw insight from the data analyzed is based on these p-values and significant level. Your understanding of this is what will enable you to interpret your results. But if you don't understand these things effectively, your interpretation of that result will be biased. Why? Because you are not interpreting it from a standpoint of a real analyst. So to establish effective, to establish standard unbiased interpretation, we need to understand the p-value. And to understand it, what is our p-value? When we talk about p-value, the word p is just the probability. The p-value is the probability that the observed result or something more extreme could occur. Remember, I said that statistics is built around the probability. That's why in mathematics in secondary school you see probability and statistics, or statistics and probability. They go hand in hand, because it's a mathematics that deals with uncertainty. It's a mathematics that deals with uncertainty. So we take the level of our certainty. Is it something we can accept? So p-value is the probability that the observed result could occur. In other words, that there is no significant difference. In other words, that the null hypothesis could be true. What are we observing? Whether the hypothesis is true. And remember, I said that we start our hypothesis from null hypothesis. So the p-value is the probability that the result could occur, could be true. That's p-value. We are getting to somewhere. Then the significant level. Your level of significance. Now your significant level is what I call a threshold, chosen by the researcher before testing. Is a threshold, is a benchmark, is a standard to which you are going to assess your p-value. It's a standard to which you are going to compare your p-value, your p-result. So significant level is a standard, is a threshold, is a benchmark by which a researcher compares the result of the analysis. And in general, in social science, generally, we make use of 0.05, which is 5%. 0.05 is our threshold, is our benchmark, is our point of reference. Is our point of reference. So when we analyze and we see our p-value, we see our result, our p-value, we compare that p-value to our significant level. And remember, a researcher, an analyst can state his own significant level. For example, if you are doing a medical analysis, you are a pharmacologist, you are in med lab, and you are doing medical analysis that has to do with life. Most times the level of significance is high. They raise the confidence interval, the confidence level high. Remember when we did data for forecasting, I talked about the confidence interval, the confidence level. So if it's medical analysis, pharmacology analysis, the confidence level should be high because it's something that has to do with life. So the researcher can state it to be 0.01, which is saying I'm 99% confident. I'm 99% confident. That's what it means. 0.05 means I'm 95% confident. 0.01 says I'm 99% confident. 0.001 is saying I'm 99.9% confident. So the significant level and the confidence level, they go in pari passu. They go hand in hand. So if they give you confidence level, invariably you have been given the significant level. If the confidence level is 99%, what you just need to get the confidence if the confidence level is 99%, what you just need to do to get the significant level is to say 100 minus 99 divided by 100. Simple. What you need to do to get your significant level when you are being given the confidence level is to say 100 minus the confidence level divided by 100. And the confidence level, if it's 95, is 100 minus 95 divided by 100. That's why you are seeing this 5% here. So having established this, which is the significant level, we move to decision rule. When you understand your P and you have your significant level, now you have run analysis and the result, your P result has shown, already as a researcher, as an analyst, you have already established your significant level. Now you are using it to make your decision. Now in making decision, please never forget this. Always practice this. Never forget this. Always practice it. Sometimes it can be confusing. Sometimes it can be funny. Now let's proceed. Now what does it say? It says if the probability, if the p-value is less than or equals to the significant level, if it's less than or equals to the significant level, we reject the null hypothesis. If the value P, we will go into practicals and we begin to see this result and make the decisions. We are going to be making our decision based on what we have here. So please, if you are following me, you can write it down somewhere and practice it, memorize it. Sometimes it can confuse you. Sometimes it can confuse you. So please note that. I'm telling you from experience. I'm telling you what I know. Most times my students, if some of them on this call, they can tell you. Sometimes you think you have mastered this. Tomorrow you begin to make some certain is it not this, is it not that? So please pay attention and get it correctly. Alright. If P is less than or equals to alpha, when we say alpha is the significant level. We use alpha to represent the significant level and P to represent the probability, the p-value, the probability value. Now, the p-value, if P is less than or equals to alpha, reject null hypothesis. What are we saying? That there is evidence that shows, we have evidence, and this evidence shows that there is significant difference, there is significant impact, that the data we analyze has statistical significance. The data we analyze has statistical significance. That's what this is. Now, if the P is greater than alpha, if it's greater than significant level, then we accept null hypothesis. We accept null. That's why fail to reject null. That means not evidence to support H1. we accept null. If P is greater than significant level, if P is greater than the significant level, we accept null hypothesis. That's why I put here, fail to reject null. You don't reject it. You accept null. So now I'm going to repeat it in a nutshell and we move. If P is less than or equals to alpha, reject H naught. Reject null hypothesis. If P is greater than alpha, is greater than the significant level, accept null hypothesis. Accept H naught. That is what we have. Let's proceed. Now, in a nutshell, I summarize it this way. Everything we are talking about, the hypothesis, everything we are talking about, the hypothesis, the null, the stuff, the p-value, everything we are talking about on the p-value, the significant level, I summarize it in these three key statements. Always remember this statement. These three statements are key. Always remember them. The first one is that hypotheses are the claims. Your hypotheses are claims, what you claim, what you assume. Your statement, your claims that we are not sure whether it's valid or not. Your assumption, that's your claims. Then the p-value are the evidence. So this claim you have now, can you show us evidence? Do you have any evidence that will support this claim? Do you have any evidence that validates this claim? Why the significant level is our courtroom? We take this evidence to court and know if these evidence are valid enough to support this. If those evidence are not valid enough, we trash it, we throw it away. That's in a simple term, in a simple fact, in a simple terms. Your hypothesis is your claims, your p-values are your evidence. When you run the analysis, you have results, and results are your evidence. These are the results. And you now take this result to court. The court is the significant level, where you go to the court and you weigh it and you check whether this evidence is enough to validate your claim. That's in a nutshell, in these three powerful statements. Now, having established that, we proceed to what we have, where we will measure this night, in when we get into the practical part to go fully into the practical details to analyze. Once again, confirm if you can hear me, confirm if you can see my screen. If you are just joining us, this is Data Analysis Scholarship course. If you are new to this course, we are on the 5th week of the Data Analysis Scholarship course. This course is a 6 weeks intensive course on data analysis using Microsoft Excel to become a powerful data analyst. The training has been paid for, the certification has been paid for. It's only your presence, your determination, your dedication to learn and to learn effectively. And then your commitment registration of 3,500 for non-core members and 2,000 naira for core members. That's all that is required. Every other thing has been settled. All right. Now, having established that I'm still on the chat, confirm if you can hear me. Confirm once again if you can see my screen. And also, if you are just joining us, I will encourage you to hit the like button. And if you are new on this channel, you do well to subscribe so that anytime we have opportunity like this, you will be notified. Anytime we go live, anytime we have trainings such as this, you will be aware from the onset and then join us live. Okay, I'm expecting those of us on this call, if you can hear me at the same time, if you can see my screen, let me know, because I'm moving into the main thing for today. Let me know we're on the same page. Let me know we're on the same page. Drop in the chat. Drop in the chat if you can hear me, if you can see my screen. All right, beautiful. I mean, good to hear that from you. We can hear you and we can see your screen. Beautiful, 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 beautiful. Okay. Now, what is t-test? When we hear the word t-test, what is t-test? Now, we say that t-test is a statistical test. It's a statistical tool used to compare means of two groups. T-test is a statistical tool. It's a statistical test used to compare means. When we talk about means, here we are talking is the same as saying average. Is the same as saying average. So a t-test is a statistical test used to compare means of two groups and determine whether the difference between them is statistically significant. So when we say statistically significant, that means it's not something that just happened. It's not a fluke. It's not something that happened by chance. It's something that there is something in it. So it's something that is statistically significant. So when we talk about this, we are just referring to t-test. When we are testing by comparing the means of two or more groups, of two groups, not two or more groups, of two groups, to determine whether they are statistically significant, whether there is a difference in their statistical significance. So when we talk about t-test, t-test is a tool that we use to test if there is any significant difference. Please note that t-test is what we use to test if there is any significant difference in the damage caused by A and the damage caused by B in the result of the student of group A and the student of group B. If there is any significant difference, if there is any significant difference between the sales of this month and the sales of last month, if we get, so is statistically we are using it to test in the mean difference, whether there is statistically significant, whether they are statistically significant. That is what we refer to as the t-test theory. In a theoretical form, in a nutshell. Now, by t-test, we have three major types of t-tests. We have three major types of t-tests. Number one, we have the one we call one sample t-test. One sample t-test, and I'm going to be explaining that and when we are to use it. Now, the beauty of this, I'm breaking this down tonight. I'm teaching us as if we are not a statistics class. I'm teaching you as if you are hearing this for the first time, and that's why I'm taking time to explain these things to the level that at least a layman will be able to understand it. And that's why I'm taking my time to explain. If it's in a statistics class, these things I will just move away to it and tell them, you already know what this is, and then we flow. However, I need to explain this one sample t-test when you are to use it. When you are to use it, a data set that when you're what kind of analysis that will warrant you to make use of one sample t-test. What kind of analysis? So now, one sample t-test compare a mean of one group against a non-value. Now, what that is that you make use of one sample t-test when you are checking if there is any significant difference based on a result against a standard. Let me explain. I'm going to use different scenario to explain this. Let's take, for example, during admission time, during the post-UTME, students that are seeking for admission wrote post-UTME exam, and the school pass mark, let's say the school pass mark is 200. Let's say the post-UTME is over 400. The post-UTME is over 400. and the school set their pass mark to be 200. The pass mark of post-UTME is 200, and the students that came for that post-UTME all wrote their exams, and the result appeared, and the result shows. Now the school can decide to check the mean of the student result and compare it to that value, pass mark of 200, to know if there is any significant difference between the student's average performance, between the student's sample mean, the student result, the student score. If there is any significant difference to the pass mark, hence you are making use of one sample t-test. In other words, the data that we are going to use to analyze is the student's result, just one column data, one column data. We are going to make use of the student result to analyze. So we can have student score. Under that column, we now have different results. Hence, we now analyze it and compare it based on the pass mark. If there is any significant difference, that's when we use one sample t-test. Or for example, you are running a retail business and you run delivery, and you state a policy that your delivery time within that location will not be more than 1 hour. When you pay and your order is processed, within 1 hour, your delivery arrives. For example, I'm just using that as an example. Or let's say, for example, there was a time, I think I heard of that, I'm not really sure about that, I heard of that, when Zenith Bank did something, when Zenith Bank put certain policy, customer service policy, that if you enter into Zenith Bank and you waste time more than 30 minutes, they are going, I think, if you stay more than 30 minutes or so in Zenith Bank and you have not been attended to, then you are going to be giving 500 naira. Then I have something like that. So let's say, for example, that Zenith Bank has that policy that if you enter Zenith Bank and we delay you more than 30 minutes, we are going to pay you for the delaying. We are going to give you, say, 500 for that delay, and apologies. And that is the 30 minutes threshold mark that Zenith Bank sets. Now, Zenith Bank can decide to say, let's run analysis, let's check our service time to our customers against these 30 minutes we set as our benchmark, against these 30 minutes we set as our non-value. So this is the 30 minutes we set we are not going to cross. Let's now check the time it took our staff to attend to our customers to know if there is any significant difference. If there is any significant difference between the time, based on the time customers are being attended to, against the time we set. So when they run that analysis, to run that analysis is one sample t-test. You are going to make use of one sample t-test to run that analysis. If you are just joining us, I will encourage you to hit the like button. If you haven't subscribed yet, subscribe, share the link to sections. I'm going to go into practicals very, very soon. That's one sample t-test. I guess we understood the one sample t-test before I proceed. If you understand one sample t-test, when you are to use it, the data and the scenario where you are to use one sample t-test, drop in the chat, I understood it. Drop in the chat, understood. Drop in the chat if you understood what I just explained. If you understood what I just explained, the scenario when to use one sample t-test, the two analogy, the two scenario I painted. If you understand that, drop in the chat. Let me know that you understood it. Let's do that. Let's do that. Let's do that quickly. If you understand, let me get that. Beautiful, I mean understood. All right, let's drop that. One or two more persons, I proceed, I will proceed. One or two more persons, I will proceed. If you understood it, what I just explained, if it's well understood, let me know in the chat. Let me know in the chat. Drop it in the chat. Let's do that. Let's do that. Let's do that. All right, I'm waiting. I mean, I'm good to have your response. I'm waiting. I'm waiting. I'm waiting. Let's quickly respond if you are with me, especially those of us in the data analysis scholarship. Especially those of us in the data analysis scholarship. If you understood what I explained, type understood. All right, Balogu Zenab understood. Okay, Shitu, Olaitan, yes sir. Yes sir, is it? Yes sir, is it that you are with me? Is it that you understood? Okay, I have gotten 2 or 3 responses. All right, let's move to the second one. Independent t-tests. Independent sample t-test. We have one sample t-test. The second type of t-test is what we call independent sample t-test. Now, independent sample t-test is when we are comparing 2 separate groups, 2 separate sample statistics, 2 separate groups, 2 separate samples at the same time. Please note that when we are comparing 2 separate samples at the same time, we make use of independent sample t-test tool. When we are comparing 2 separate samples, 2 separate sample statistics, 2 separate samples at the same time, we make use of independent t-test. Anthony, good to have you. Well understood. We make use of independent sample t-test. Example, if you are comparing, let's say for example, the WAEC result. If you are comparing the 2025 WAEC result of Osun State students to Oyo State students, if you are comparing 2025 WAEC result of Osun State students and Oyo State students, to know if there is any significant difference, that is independent sample. These are 2 separate groups. One is Oyo State, the other one is Osun State. And we are talking about the same time, the same period of exam, 2025. Not that we are comparing their 2025, we are comparing this one 2025 and we are using 2024 WAEC result of Osun. No, the same time. That's independent sample t-test. Separate groups, separate sample at the same time. That's independent sample t-test. Then the next one is what we refer to as paired sample t-test. Paired sample t-tests. Paired sample t-test is when we are comparing the same sample statistics, the same sample at different time. Are you getting the stuff now? This place is where it might get a bit confusing. In paired sample is the same sample, but different time. Independent, 2 different samples, the same time. Paired sample t-test, the same sample, but at different time. For example, if you are comparing students, their result when they are in SS1, and the same student, or let's say their result, first term result and second term result, I think that's the best way. Or second year student or year 1 student, you are comparing their first semester result to their second semester result to know if there is any significant improvement, if there is any significant development, any significant improvement, if there is any significant difference. If we are comparing the same students, their performance in first semester and their performance in second semester, the same set of students, then that's paired sample t-test. But if you are comparing OAU students, year one of OAU students performance in mathematics, and year one of UI students, University of Ibadan students, year one in mathematics, if you are comparing them at the same time, then that is independent. Or you are comparing staff's performance, staff productivity before training and staff productivity after training, to know whether the training has effect, to know whether the training has positive contribution. You are comparing the productivity of staff before the training and then the productivity of staff after the training. These are part of stuff we do in HR analytics. These are part of stuff we talk about in HR analytics, to talk about staff productivity, their productivity in before and after. That's paired sample t-test. So to know if there is any significant difference, whether there is a positive significant or whether it's a negative significant, if there is any significant difference. So if that is the case, then you make use of paired sample t-test, and these are the three core t-tests we run in an analysis. And t-tests are one of the mostly used analytical tests in data analysis. I know we have basic tests, but t-tests are the mostly used in the field of analysis. It's widely used, whether in business, whether in health, in research, whether is used across. In research, in health, in business, telecom, t-test is highly used. So irrespective of where you find yourself, there are times you make use of t-test in your data analysis. All right. Now, having established that, we will quickly get into the practical to know how we can run one sample t-test and interpret it, independent t-test, and paired sample t-test. Okay, now let's get into Excel and then do justice to that. Do what we know how to do best by the special grace of God. All right. We go to that. I have my data already. Here we are in Excel. Let me know what you can see right there on your screen. Let me know what you can see on your screen. Let me know what you can see on your screen. Much appreciated. And before I commence, I want to be sure that we all on the same page. I'm waiting for us to come so that I know we are all on the same page before I move into the analysis proper. What can you see right there on your screen? What can you see right there on your screen? We are going to make use of some data sets. All right, ABC store, yes. Sales analysis sheet, beautiful, beautiful, beautiful. Okay, now, remember we said that one sample t-test is when we are analyzing one column. That's why we have this. This is a one sample t-test stuff. And what do we have here? What are we looking at here? We want to test if there is any significant difference between this and our average mean, our average sales. Let's say we state that our let me call it mean sales. let's say mean sales to be 500 rather. Now, we want to check if this, our average daily sales, whether this result, we have this data set here, 30 days. Let's say these are daily sales for 1 month, for 30 days, and we are saying that at the end of the month, our average sales should be 500. And we have this, and we want to check if they mean, if the data we have here, if there is significant difference between this and this, if there is any significant difference between our sales to the standard, this is what we expected, that every day we should make at least a minimum of this. Daily we should make at least a minimum of this. If not, that at the end of the day, this should at least a minimum of this. Now we are now going to run our analysis to check if our data, if the sales we have, if what we have here is statistically significant or not. If there is any significant difference between this to this, or if there is not. Remember, we are saying our hypothesis. Remember that our hypothesis. Remember our hypothesis is there is no significant difference. There is no significant difference. He's saying there is no significant difference. Let me put it here. That's our hypothesis, which is H naught. That's our hypothesis. We are saying there is no significant difference. There is no significant difference. Now, to run this, we are going to make use of our data analysis toolkit. Remember, in the previous session, in the previous session, I showed us when we talked about the descriptive statistics, I showed us how to activate your data analysis toolkit. So to analyze the one sample t-test, we are going to go to data, come to data analysis. Please pay attention. It's getting a bit tricky now. Now, when I click on the data analysis, if you search here from top, if you search for one sample t-test, now, if you search for one sample t-test, let's start from below. We have the c-test, the t-test, two sample assuming equal variance, t-test paired two sample means sampling, regression, rank, random, this one histogram, and histogram, Fourier, F, this. If you go further, you will see that we don't have one sample t-test here. Hence, for you to run one sample t-test, we are going to introduce another column. Now, this column, I'm going to call it me. Let me call it me. Or let me call it mean, or S underscore mean. Let me put it that S underscore mean, the standard mean, or sales mean. Let me say that sales mean. This is a dummy. Let me just say that what I'm putting here is just a dummy, so that I can run my one sample t-test. It's just a dummy. Please follow me. And since we are comparing this to this, we have to come here and type 500. Now, and this 500 will be all. We make sure the 500 is for all this till where this one stops. So here is our resales data, here is the sample standard. Now, having done that, the next thing we have to do now is we go to data, come to data analysis. Under the data analysis, we are going to make use of this paired sample, the t-test, but the paired one. We are going to compare this to this pair. We are going to remember the same pair is talking about the same data for different time. So we are going to make use of paired, and then we say, okay. Now, having done that, this dialog box will show. Now, let's remove this. Let's remove this. Now, when this dialog box shows, your own here will be empty. Here will be empty. Now, you come here, Control Shift down arrow. Oh, no, that's not for that one. The range one is the first one, which is your sales. Here, Control Shift down. Okay, now here you also go up. This one will be for this dummy. Control Shift down to select and lock. If you look at this place properly, you will see that this is for D, this is for E column. Here the hypothesized mean difference is 0, because here we have the mean already. The hypothesized mean difference is 0. I'm going to show us another way. So either way you make your choice. So here it becomes 0. The alpha here is the significant level. So if your significant level is 0.01, you put it here. But here we are making use of the standard significant level. And then the output range, I select the output range here. So inside this place, let's say I want my output range to be, here. I click where I want it to start. I click here, and then I say okay. That's all we need. Highlight this, the sales and the dummy data, and then select your label. That is showing that this label is for this daily sales and sales mean, and then this one remains 0. If your significant level, which is here is called alpha, is not 0.05, if you are making use of 0.07, 0.02, 0.01, 0.03, as the case may be, you select here. And then the output range, if you want it this in the same sheet, which I mostly do, you select the output range. If you want it on a new worksheet, you want to send that particular result separately to someone and return that, the other one, that's fine. You put it on a new worksheet. If you want it new workbook, you select new workbook as well. But here, I want it here, then I say okay. Now, automatically, our result comes out here. We have our result. Here is saying t-test, paired sample for means. Now, when you look at this, you see the result we have here. We see that the result we have here is something that we need to explain. Now, when you look at this, this is the mean, and this is the major one we are talking about. I can go ahead to delete this, but I will leave it here. The observation is 30, this is 30. Now, the mean is this, the variance is this, the hypothesized mean is this. This DF means degree of freedom. This is the T statistics. Now, the P, this is a one thing. Our result is 1 thing, because this one sample T test. We are going to make use of this. The T less than or equals to T, 1 thing. Now this one tail we have here, this is our p-value. This is our p-value. Now remember, I'm going to do a simple check now. I'm going to do a simple check. Please confirm if you can still hear me. Please confirm if you can still hear me. I think I'm experiencing some lag from my end. Confirm if you can still hear me, please. Okay, now I'm going to be doing something. I'm going to be asking us a question now. Those of us that have been with me, remember this becomes our p-value. Let me highlight it. This becomes our p-value. Okay, this becomes our p-value. Thank you, Amina. Now this is our p-value one tap. Now what can someone tell me what we are going to do based on this p-value when p is less than or equals to alpha? When p is less than or equals to alpha, what are we going to do? When p is less than or equals to significant, let me put significant when p is less than or equals to, when p is less than not, yes, when p is less than or equals to the significant level, what should we do? What will be our decision? Because what we have here, remember our s dot l, which is significant level, our significant level is 0.05. Let's note that. Let's remember that. Our significant level is 0.05. Our p is this. Now, if p is less than or equals to 0.05, what will be our decision? Let me hear from us. Type in the chat, what will be your decision? Beautiful, Amina. Beautiful. Reject the null when it is less than or equals to significant level. Beautiful. Now, what that means is that we reject the null hypothesis. So what this entails, what it means is that based on our result, we can now say that there is significant difference between the sales mean against the sales, say, I can call it the sales standard or the sales target. So let's say we have a target. Our target is to make an average of 500, and we have here the same, there is a significant difference between this and this. Now what we will now do is we can now come, since there is a significant difference, we can now run the mean. We can now say sales. To find out the difference, we can now say sales mean minus sales target. So to do that, we can have it to be equals to this minus this. We hit enter. So we are having an extra, a positive difference. That means there is an improvement. There is a positive improvement of $14.83, 83 naira, 83 whatever currency you are making use of. So we have a significant difference in the mean. Remember this, the mean of this against this. In the mean of sales we have as against the target. So we surpass the target. Averagely we surpass the target by 14.8. That's what we are talking about. That's our interpretation. There is a significant difference. There is a significant improvement. There is a significant development based on the data before us. Now we have been able to analyze this data using Microsoft Excel and then have our insights. Here the main point is to determine your P, to see your P value. This is your P value, one thing you are going to be using. Now let me show us another way we can run this particular analysis. Another way we can run this analysis. Let me show us another way. Now here, another way we can run this is to come here. Let's highlight this and delete. And here you can still put 0, your choice, any of them. Just put 0 or type 00 or this dummy. This is a dummy. And then you go to your data tab, come to analysis. Under analysis, you are going to select, I think, this one, and then this. Yes. Now once you do that, here you have this. Select, then here you select this one as well. And then you come to your hypothesized mean, and you now type the 500. You type the 500. Now once you type the 500, select your label. Under the label, on the range, I'm going to output. I'm going to select the output where I want it to be. Okay, let me select this place where I want the output to be, and then I say okay. Now we have this. Now we have this. Let me zoom in a bit to see if I can have the same stuff on one screen, but let me leave it. Now if you notice, you will see that the mean is still here. All things being equal, what we now have here is 0. This the mean, this is the variance. This now what we are, this against this. So here I can delete this one, is not helpful for me. I can delete it. So what I'm checking against is this one against the standard or the target. This is our sales target. This is the mean, sales mean. We compare if there is significant difference between this and this. And by that, we see that our P is this 0.003, which is still less than. And this one is 0.005. So when you look at this, there is not much stuff between this one and the other one, which is, this is less than 0.005. So either way, but the one I strongly recommend is the first one. I strongly recommend this first one. That is the first one is what I strongly recommend you can make use of it. All right, that is on the that's on the aspect of the t-test, one sample t-test. Now let's move to the independent sample t-test. Now under the independent sample t-test, I have this data. I'm going to be making use of this data set. Okay, I believe we can see it much better now. Okay, now here we have these data sets. We have a group of sales spaces. Group A, group of sales from group A and sales from group B. Let's say sales from Ocean and sales from our office, or our office from Ocean and sales from our office in Oyo State, for example. So this is their sales, this is the sales, and here we want to compare their name. We want to compare their average sales and average sales of this, if there is any significant difference, or if there is no significant difference. So this is two separate groups at the same time. Their monthly sales, let's say the sales in the month of July, we are in August. The sales in the month of July from Oyo and the sales in the month of July from Osun, our sales persons, to know if there is any significant difference. So in that aspect, we can go to our data tab, come to data analysis. Here we are making use of independent. We are assuming equal variance. We are assuming equal variance. All things being equal. Equal variance. Under the same factors. There are no, in Osun State, there is no natural disaster. In Oyo, there is no natural disaster. There is no political crisis. There is no, under normal circumstances, under all things being equal, ceteris paribus, all things being equal, that's our assumption, assuming equal variance. There are no extremes. So we select this and we say okay. Now we are going to delete this. We are going to delete this as well. Here we come and click here now. For range 1, variable range 1, we select this, Ctrl-Shift down. That's for variable range 1. We come to variable range 2, which is this, Ctrl-Shift down. Here we remove this and we select 0. We are assuming no differences. Everything, all things being equal. Here we have our label under 0.05, and then where do I want this to display? I want this to show here. I want it to display here, and then I say okay. This is now my independent sample t-test. This is my independent sample t-test. Now, when you look at this, we are making use of the two-tail. This is comparison of two variables. So here we are making use of two-tail. This is where our P is. For one sample t-test, we make use of one tail. For independent sample t-test and paired sample, we make use of two-tail. And who can tell me what we have here? Who can tell me the results? Someone type in the chat. Type in the chat. If you can still hear me, let me know. Let me know if you can hear me. Let me know if you can hear me, if you can still hear me. And also, if you can hear me, please, I want someone to type in the chat what will be our decision. This is our P. Someone what should type in the chat what will be our decision. This is our P. This is our P value. Someone type in the chat what is our decision. Should we accept null or should we reject null? Let me hear that. Let me get that from us right away. Let's do that. Let's do that. I'm waiting. I'm waiting. Should we accept null or should we reject null? Based on the result we have. Based on the result on your screen. Should we reject null or should we accept null? Let's quickly do that. Let's quickly do that. Let's do that. Let's do that. All right. We are getting there. We are getting there. After this, it will be paired sample t-test and we call it a day for today. Tomorrow, we will be going over to ANOVA. You will not want to miss it. We will be going over to ANOVA and correlation. Can someone hear me, please? Confirm. Can hear me, please? Confirm. If you can hear me, let me know. And can someone else, if you can hear me, let me know. And can someone else try to see? Please, are we good? Are we good? Can someone let me know in the chat? Are we good? Please let me know in the chat so that if you are good, let me know, we can round up. We are, like I said, we have one more to go. I think we are back. Can someone confirm if we are good now? Okay. Can someone tell me what you think is your answer? Should we accept null or should we reject null? Should we accept null or should we reject null? Anina said we should reject null. Amina said we should reject null hypothesis because P is greater than. Okay, now without further ado, let's explain the data together. Let's explain together. We are good now so that we don't stay to. Let me zoom that in more so that now when you have this in Excel, when you have 5 point this E, this is showing you E minus 0, 0 up to 8. So it's showing you that this is showing you this, that it means this value means something like this, 0, that this value means something like this, 0.00000, I think, stuff like that, 5. Yeah, I mean, I know. I think it's something like this. This simply means, let me type it in a way that it simply means 5.318, for example, approximately times 10 times 10 times 10 raised to power 8 times 10 raised to power minus 8. That's times 10 raised to power. I'm looking at what to use to times 10 raised to power minus 8. That's what this value means. This means this times 10 raised to power minus 8. So if we convert it, this simply means 0.000000. That's 7 zeros. Then 5.318. That's what this value means. So we need to understand that. We need to understand that very well. This value means this. So as you can see, immediately I type this. Immediately I type it, it gives me stuff to this. Can we see that? Immediately I do that, Excel automatically approximate it, do that to this. So what this means this. This times 10 raised to power minus 8, which is this. So with these results, can someone now make decision? Having this now, can you now make the correct decision? So you need to understand the results. You need to understand the data. You need to understand your results so as not to make a decision that is not in line with what the result is saying. It will, so that it will not be in line with what the result is saying. Now what will your decision now be? Can I see your response now, having established this? All right, you get it. The exponential, all right, you get it, is less than. That means we have to reject the null hypothesis. That is to say, there is a significant difference between group A and B. So what we will now know from their mean, we can now get the difference. From their mean, we can get the difference, and that. So on our own, we can now write it based on what we have here. Okay, let me now write the interpretation here for us. Let me freeze this place. Okay, so here we can now say there is significant difference between the mean value of group A cells to group B cells. So that's what we have. Here we can now, let me be fast, Control C, paste it here, Control V, and then we can now have this minus this to determine the difference. But here we are not looking at it either way. The higher one can subtract. We can have this to be B, can subtract this one. So once, if that is the case, we can now say equals to this minus this, and that's the difference, 32.76 or 32.77. That's their mean difference. So we can comfortably say there is significant difference between this and this. Then we now state that, we now say that P is less than 0.05, comma, then we now state our P value. P equals to 0.000005138. I think so. I think that's the value. So we set the value. Now this is this minus this is this, the mean difference. This, I think also the mean difference should be here. I think, did they put it here? No. If it's SPSS, SPSS will give you the mean difference. If it's in SPSS, you will have the mean difference. Okay, now this is the mean difference. You now have that P. Why did you state this? Why you say this is that P is less than 0.05. And because it's less than 0.05, we reject null. And that is what we do. And then you can put your degree of freedom. After that, you can type in your DF, your degree of freedom to be equals to 58. 58. That's your interpretation. That's your interpretation. All right. Now, we have understood how we can interpret these data sets. Okay. Now, having established that this is our interpretation, let me zoom in a bit so that we see everything together. And let me move up a bit. We see this. Okay. Now, this is our result, this is our interpretations, and what have you. Now let's wrap up with the paired sample. Paired sample, we are looking at training. After training, this result, sales result before training, and sales result after training. After training the employees, this is the result after, before training, and this is after training. We want to know if there is significant difference. If there is significant difference. So to do that, let's quickly go to analysis, and then remember the same Here is the same employees. This is the result before the training. This result after training. So we want to analyze them, and we are going to make use of paired. This is the paired sample t-test. We select this, we say okay. Now here we are going to remove this and then select this one before training. Hold Control Shift. That is the range. We come to this one. Let's delete this. And we select this, Control Shift down. Then we are assuming no mean difference, 0. The label is because we have heading. If we don't, then we can unmark this. We are making use of 0.05, which is our significant level. And output range, let me remove this. And for the output, I want it to be here. And then I will say okay. So this is what we have. Let me increase it. This is what we have. And from this, I need you on your own now. I need you to interpret this. I need you to interpret this result. This is before, this is after. The variance, we have observation, the correlation, there is the correlation, Pearson correlation coefficient. Is this, we are going to be understanding what correlation coefficient is, what is correlation, the strength in correlation and the direction. All right, we have the degree of freedom, we have the t-test, and then we have this. In the t-stats, this is the 2T. That's what we are going to be using. So what you will do on your own, look at this result, interpret it, and give it to me tomorrow. Look at this result, give me the interpretation. All right. Now, the assignment for today, today's assignment is generate a data set for one sample t-test. Run one sample t-test of student pursuit TMA results against 200 pass mark. Generate the data set of student pursuit TMA results. Students pursue TMA results against the pass mark of 200 and do it for 200 students. That means the result you will generate will be 200 for 200 students. That means you are having 200 rows of result. You are having 200 rows of result. Do that for one sample t-test. Then generate a data set for independent sample t-test as regards to business. Let's say as regards to sales. As regards to sales, generate a result, generate the data set for independent sample t-tests. For our store, just let's say we are working on ABC store, then the store or your store and Ocean store, let the sales result be also 200 for independent sample t-test, and then generate a data set for paired sample t-test comparing students' results, first semester results and second semester results for 100 students. For 100 students, comparing first semester results and second semester results of 100 students. That is our assignment for today. Today's assignment is this three: one sample t-test, independent sample t-test, and paired sample t-test. Generate it, analyze it, and interpret your results. Generate the data set, analyze it, and interpret your results. Generate the data set, analyze it, and interpret your results. I believe I'm clear, we are clear with that. Generate the data set, analyze it, and interpret your results. And it's on this note that we have come to the end of today's section. Tomorrow we are going to be looking at the ANOVA and correlation. It's going to be an awesome time tomorrow. You can't afford to miss it. Tomorrow we are going to be looking at ANOVA and then correlation. Thank you. Now is my attendance. If you are with me here, drop your name and your scholarship ID. The attendance, your name and your scholarship ID. Your name, your scholarship ID, and also let me get your feedback. How is the section tonight? How is the section this night? Let me get your feedback. How is the section this night? Your name also and your scholarship ID. That's much appreciated. Your name, your scholarship ID, and also your feedback. Your feedback, how is tonight's section? Let me get that from us. I'm done for tonight. We are done for tonight. Let's drop our names and scholarship ID. Much appreciated. And let me get the feedback. How is the section tonight? How is the section tonight? Okay, we will be dropping here. See you guys tomorrow, same time. Do enjoy your night rest. Good night, everyone.